now screen? Hey.
Yes, sir.
Okay, so this is just like the model, the sample of assignment 3, that what is going to be given to you. Okay, now look at this. All what you have to solve this problem, and this is the one, actually the gain of the preamplifier. You have to solve it according to your student ID, and using the uh, Simulink, MATLAB Simulink, you have to design the, this is a question actually. You have to first find the transfer function for the plant, then you have to implement it into Simulink, and after that you have to check the result are giving the same result. I'm talking about these 3 things actually. I have to implement it. Okay, that's all about what you have to do in assignment 3. I will finalize it and upload it into the Vuex and give the deadline, and you have to solve the problem. So this is very much you need to know the Simulink, MATLAB Simulink, and that tutorial I'll attach with this thing, so that you can go through the tutorial, you can understand how to do the Simulink. Most probably you have to go with the Scilab Simulink, Scilab simulation, which is a French company, is a free resources. I am planning to ask you to learn that part, because MATLAB Simulink is okay. You all know from EEE CSA 330 numerical method and all that. But Scilab is another free resources, so very much alternative to the MATLAB Simulink, and I think everybody should need to know that one. It's very much powerful and resources and open source from French company. So science laboratory, it's a science lab, Scilab. So that one we'll discuss later, and you'll see it in the, that is what I'm talking about, the assignment 3. And you have to, very simple, you can easily solve the problem for assignment 3. But very much interesting, so that you can get some clear picture or get some interest about the control system topic. Okay, now that's all about the assignment discussion and the weightage of the marks and everything. Now let's go with the class today, that what we are going to talk about, the new topic we're going to start, that is stability analysis using a method which is criterion by Mr. Ruthian. So according to his name, this criterion is called Ruthian stability criterion. The Ruthian Hardwick stability, Hardwick is another guy together have developed, but normally everybody is talking about Ruthian. So it is a Ruthian stability criterion according to his name. We call in short RSC. Now, in order to start with these things, I can tell you one thing all of you know, stability, we have come to a decision last time that if the closed loop poles, try to remember, if the closed loop poles are located on the right half plane, system is stable. That one you remember. And if any of the pole, any closed loop pole, any closed loop pole, any closed loop poles located on the right half plane, system will be unstable. So for the system to be stable, all the poles must be on the left half planes. No poles should be on the right half plane. That's what we have come to a conclusion. So this, based on that information, we are going to find out, we are going to apply the Ruthian stability criterion on the system, and then we are going to determine system stability. That's what is today's class. So let's go with this thing. Now, first of all, what we are going to start from is, you know that in general, we can write the closed loop transfer function C by R. If we want to write in general, if you want to write like that, C by R is equal to, for example, the closed loop poles and open loop and closed loop zeros. On the tops are closed loop zeros. So if you say that this is B0 and s to the power m, then you can say B1 s to the power m minus 1. Like that way, if you carry on, then what will be this? The last one will be Bm and s to the power 0. And this one will be s to the power 1. And this one will be Bm minus 1. Bm minus 1. and the earlier one will be s square and s to the power b minus 2, like that. And similar way, if you go for a on the bottom of the denominator, that is s to the power n, if you can say that a1 s to the power n minus 1, like that way. If you go same way, you can go like this, s to the power 1 and a n minus 1, a to the power n minus 1, and this one will be a n, so that you can say that again n is equal to or more than m, so that the denominator is more than the numerator. It's a partial fraction, you can say a proper partial fraction. So this one, we can say how many poles, how many zeros. Definitely you can say there are n number poles, m number of zeros, and a number of poles more than, so that it is a proper fraction, partial fraction. So this is what we can say. The C by R lower part is the poles, the closed loop poles, if on the located on the right half S plane, on the right half S plane or not. That's the main thing we have to go. And if it's a factor, it's a polynomial form. Without a big polynomial form, we don't need to factorize it. We can straight away. If you have a factorization, then you can say how many poles are on the left or right or something like that. But if it's a polynomial form without factorizing, we can easily find where any pole is located on the right half S plane or not, according to Mr. Ruthian criterion. That criterion, now we are going to see whether any poles are on the right half S plane or not. Let's go with the pole, and this pole actually equal to 0. If you write the bottom part equal to 0, that is called, I told you already, it's called characteristic equation. Characteristic equation. This gives you the character of the system, like system stability performances. So equations are like that is equal to 0, which is nothing but 1 plus GH equal to 0 as well, because the lower part is coming from 1 plus GH, and that's what also can be, and this is in general equation also can say like that. So Mr. Ruthian, he had taken this characteristic equation, which is a big polynomial, and from that polynomial he actually found how many poles are, closed loop poles are located on the right half S plane. Now if we take his equation, the characteristic equation here, then we can see the characteristic equation according to him is coming here as a naught s to the power n plus a1 s to the power n minus 1, okay, plus a2 s to the power n minus 2 plus a3 s to the power n minus 3, then a4 s to the power n minus 4 s to the power n minus 4 plus dot 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 go on up to the last one is a n equal to 0. That is what we can see. Now Mr. Ruthian, what he did from here, he had developed a array. He had developed an array, and according to his name, that is called Ruthian array. So that is what our main things to develop first. After getting the Ruthian array, then you have to do the analysis to find out the number of closed loop poles located on the right half S plane. Now, how to construct the Ruthian array, that is the first thing we have to check. Now, if you want to construct the Ruthian array, how he did, he had first make a column where on the left hand side, starting from the s to the power n maximum, and then s to the power n minus 1, there's a maximum, the power of s, which denotes order of the system. N order means s to the n minus 1, n minus 2, n minus 3, and so on. It will go up to s to the power 0. So this is the way he, really at the left side column, He had written like that, all the S parameters. Now, on the right side, he developed the matrix, and the matrix, how he developed, all of you please look at it very carefully. First of all, he took the first element, that is the coefficient, then omit the next one, then take the following element, then omit the next one, then following the following element, then omit the next one, then take the following element. Like that way he continue taking the thing. If it is the thing they take, that means first element is a s to the power coefficient is a naught. Next, this is the way he completed the first row of the array, and then you go for a2, then you go for a4, like this way you have to go. And what will be the next one? What do you think over here should be? Yeah, I told all of you to keep the microphone unmute unless it is making any noise, so that you can answer me directly. Okay, good. It is A6 because it's a hidden there. A6, then A8, like that way it will carry on. Now, if you go for the one which is living, that one he did not consider, those things, if you go for the next row, which will be a n coefficient coming from here is a to the power n, then is coming here is a to the power 3, a to the power, what will be these? 5, right. The 5, a to the power 7. Likewise, you can carry on. That is what the way you can write the second column. This is the way you can fill up the first two row. I'm sorry, not column. First two row, first row and second row, you can straight away fill up from the characteristic equation given in the problem. After having the first two row, then Mr. Ruthian's main contribution started, that he started trying to find out the third row, that is what will be this element, what will be here, what will be here, what will be here, like that. He actually get the third row from the calculation. So how he got the third row? Let's say the third row he assume a B, let's say B1, this is B2, this is B3, assume B4, like that way. Now, what is the value of how he got B1, B2, where he got from? He got this B1, B2, B3 values. He calculated it from the above two row, row 1 and row 2. These two row actually given him the information of B1, B2, B3, and B4. So if you go according to that, then you can see the B1 is like it is coming from the above two row in this way. That is your the above one, A1 is considered as a base, and he multiply A1 and A2. That is, I'm going to write here, A1 into A2 minus these two, A2, A3, and A0. So A0, A0, and A3 divided by the base 1, A1. So this is the way. That means he got the B1 equal to, just I'm writing here, A1, A2 minus A0, A3 divided by A1, the base 1. This is the way he written the A1 value. And similar way, he can find the B2 value. So if you follow the same way, the B2 will be this A1 into A4, A1 into A4, A1 into A4 minus A5 into A0. So A0 into A5 will be this divided by the same one, A1. So B2 will be like this actually. So B2 will be A1 into A4 minus A0 into A5 divided by A1. So this is how the B2 should be calculated. And how B3 will be calculated, Can anyone tell me how B3 will be calculated?
A1 A6 minus A0 A7.
Good. A1 A6 minus A0 A7 divided by
A1.
A1. A1 is always the base unit, so it should be divided by that. So before, I'm just asking one dumb. Okay, who told me this answer? Sumaya.
Maimuna plan.
Okay, Sumaya, can you tell me? Then Sumaya, tell me what will be before? Can you? Sumaya? Oh, Sumaya, can you hear me? Sumaya is sleeping. Anybody voluntarily want to tell me?
Sir, A1, A8 minus A0, A9 divided by
A1, A8 minus A0, A9 divided by
A1.
A1. Good. So next one will be here. A6 means it will be A8 and it will be A9. So it will be like that. So good. So this is the way actually Mr. What his name? Ruthian, Mr. Routh actually had calculated all the B row, B1, B2, B3, B4. He calculated in this way. I hope that all of you understand it, how to do this calculation. Now, after that, he gone for the third row, fourth row, and then the following row maybe this one we can say, let's say this one we can say C1, then C2, then C3, then C4, like that way we can carry on. Now, what Mr. Ruthian had done, he had calculated the C row he calculated from just above 2 row. Just above 2 row is this row and this row. There is a second and the third row. So he calculated the C1, C2, C3 is just from the above 2 row. And the above 2 row are, if you go for this one, then it is B1 is the base, A3. So B1 into A3. So you have to do these things. B1, A3 minus B1, A3 minus B2 into A1. So it will be minus B2 into A1, B2 into A1 divided by B1. This is the way he did the thing. So if I go for C2, equal to what? The same way if we go, can you tell me now, Saud Noman, can you tell me what will be C2 equal to? The B1 into what? B1 into what? I just show you here.
Yes.
Oh, you cannot see. Okay.
I'm seeing, sir.
Okay. B1 into A5.
B1 into A5 minus
A1
into
B3. B3. Good. Divided by what?
Divided by
B5. Base unit. What is the base unit? Base unit is the first one.
yes, sir, B1.
B1. Always base unit is same. So when you go for this one is a B1 down. When you find C3, you have to divide by B1. When you find C4, you have to divide it by B1. So B1 is a base unit. You have to divide always the same B1. So the same thing. This is the way. Good. Your answer is correct. Now let's come back to the next one. Let's come back to asking question. Okay, I'm thinking that you don't like it asking you question, and because you like to relax, no concentration in the class, no problem, like that. Okay, no problem. I am just going to tell you the question, and that's okay, no problem. Voluntarily, you can give me the answer because I saw one guy dropped already. Asking question means you don't like it, no problem. But some of you. I'm asking you voluntarily, you give me the answer, please. And keep your microphone on and you
B1 A7.
Go ahead. B1 A7 and try to understand everybody. If anybody got question, please.
Minus A1.
Minus A1.
B4.
B4. Good. Divided by?
Divided by B1.
Yeah, B1. Everybody need to understand because why? After this, I'll give you a problem and you have to solve using your calculator, and you have to do this calculation. If you don't understand now, you cannot do the calculation, please. So everybody should understand what is going on. Okay, this is C3. You can get the C3, you can get the C2. Now C4. What will be the C4 on the top? Can anyone voluntarily tell?
B1.
Okay, B1.
A9
B1, A9, good.
minus A1 B5
A1, B5 divided by
divided by B1.
B1. So this way, actually, the C row can be calculated. So you all understand. Now, if I go for the next row, like this, let's say I'm writing here D1, D2 row, D2, D3, D4, for example, the next row, following row. So D1 will be, from common sense, D1 will be what? Can anybody tell me?
B1, B2 minus
No.
B1.
I'm sorry, come again. Can you tell me again? What? Repeat.
D1, B2.
No, D1, D2 is wrong, because D1 you are finding. How come D1, D2?
D,
C1 B2 minus
C1, yeah, that's right. C1, B2
B2
minus what?
B1 C2
1 C2
B1, C2, right. This is
divided
the
by C1.
divided by C1, because you have to calculate it from the above two row, remember. So you cannot use the D1, D2. So you have to go for it. Now D2, if I ask you, D2 will be what? What will be the answer, D2?
Sir, C1 B3 minus B1 C3.
C1, this C1, first one was this and this. Now C1 will be B3, right? C1 B3 minus C3
B1 B1.
C1 C3. C1 B3 minus what?
C3 B1.
Right. C3 B1 divided by
C1.
C1. C1 is always same. So this is the way you have to get the answer for this. Now, I hope that all of you got it. Now I'm going to complete the D row, and then we can jump to the conclusion. Now, can you tell me next D3 will be what? Anybody?
C1 B4
C1 B4, good.
B1 C4 minus B1
I1 C4, excellent. Divided by
C1
C1. That's the way actually you all understand that this one will be multiplied with this B4, and that one C4 will be multiplied with this B1. And that's the way you have to find your answer for C1. Like that way you come up to the last value, which is S to the power 0 up to the last. So you can see it is going to be a lower triangle like something like this. S to the power n, S to the power ting tong ting tong ting tong. And this is going to be having some value, A1, B1, some value, C1, B1, like that. Then you get some value here, get some value here, and then some value, there's some value, and get some value. So these are some value 2, 3, 4, 5, whatever, 5, something, upper triangle. The lower triangle is all 0. So this is 0, 0, 0, 0, 0, 0, 0, 0, 0. This is all 0 triangle, and that's all upper. So upper triangle, you are getting some value, lower triangle is, so the array will be something like that. You will see once you do the calculation. Okay, now the Ruthian array, Mr. Ruthian, once he developed the array, then he looks for what? Then he consider, after finding this array, then he considered the first column. Then he looked through the first column. This is the first column. Okay, so he considered the first column. He looked through this. After getting the Ruthian array, what he did, I'm just checking, he will look into it, and he go from top to bottom. He go from top to bottom direction, top to bottom direction, and he see how many times sign changes. He is looking for how many times sign changes here. That is giving him the information about how many closed loop poles are located on the right half S plane. There are altogether how many closed loop pole? N number of closed loop pole, because S to the power n, factorize it, you get n pole. This is a n pole, right? N pole. So n number of pole, among the n number of pole, how many poles are on the right half S plane? That is the information we need. And if there is one single pole on the right half S plane, system will be unstable. So if there is 0 changes, that sign change, then you can say it is a stable system. And no poles on the right half S, all the poles are located on the left half S plane. That's the way we have to go for. Now, you understand how to construct the Ruthian array, or you have any question? Tell me. Hey, got my point what I'm talking?
Yes, sir.
Yeah. So if you, do you understand actually, or you have some question about this? Tell me.
We understand, sir.
Okay, if you get it, then I'm going to give you a problem and you try to solve it. If you can solve it, then I can understand that you got it. Let's say I'm giving you a first problem, problem 1. All of you please take it on your paper and solve it and give me the answer. You have to participate. Sleeping and looking at and doing nothing is not the way. So let's say the characteristic equation, the characteristic equation is given here. Normally we can write QS or PS, whatever, equal to something QS normally written, QS equal to, if it is written like that, S to the power 4 plus 2S to the power cube plus 3S square, for example, plus, for example, 4S plus 5 equal to 0. Now, can you construct the Ruthian array for this one first? First job is find the Ruthian array for it. Ruthian array. Okay, what will be the Ruthian array? Can you tell me? It will be starting from S to the power what?
4.
4, good. And then S cube, then S square, then S to the power 1, then finally S to the power 0. Like that. Now you fill up the Ruthian array. Tell me what is the answer. Anybody, if anybody done it, let me know. Do it faster. Okay, if you complete it, then you unmute, and then you can tell me the answer. Anybody done? You please unmute and tell me the answer. What will be the first row? What will be the second row? I think the first row and second row, anybody can answer.
Yeah. 2, 4 on the first.
Okay, you want to say the first row, right?
2, 4.
Okay, just a minute. Okay, can you tell me again? First row is what? 2.
4.
On the no, here what will be here? 2.
1, 3, 5.
Right, 1.
5.
Okay, 1, 3, 5. And what will be the second row?
240.
240. 0 you can write or don't write, same thing. Okay, now you go for the calculation for these, like that. All things you have to calculate. This will be 0 automatically, so you don't need to go. Only these points you have to calculate, should be fine. Once done, tell me the answer. Okay, S square row. Anybody calculate a S square row? What will be here?
1.
1. And
150.
1, 5. Okay, 1, 5, 0. 0 you don't need to write. 5. Then S to the power 1 row. What is the S to the power 1 row?
-6, 0, 0.
minus 6, 0, 0, don't need to write, okay? And the s to the power 0, what is that? You can write, listen, you can write 0, 0, no problem. Or you don't write, no problem as well. What is that?
5.
S to the power 0 is 5. Do all of you agree? You are in trouble. 2 multiply this divided by 2.
Yes, sir.
3 minus 4 into 1 divided by 2 is giving you what? 1, is it?
Yes, sir.
But that's the way every point you have to calculate, and this one is here. Like 1, 5 minus 6, 4, 5. You can calculate it by yourself and get the answer. So I hope that all of you got it. Okay. Hey, all of you got the same answer. Please faster. Okay. Yeah, if it is, if
Sir.
you don't get it, copy it. Don't waste time. Now look at it. I told you, Mr. Ruthian, look at the first column. This is the first column you have to look into. If you look into the first column and go from top to bottom, from the top to the lower part to the bottom, how many times sign changes? Can you answer the question?
Twice.
Okay. Do you all agree what he said? You could not understand what he said. Hey, can you talk clearly? How many times?
Twice.
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 Okay. Okay. Now look, how it is twice. Let us see. From this is plus. Okay. This is just going to delete it. Then it will be easy to understand. Okay. Now, if it is considered, this is plus. This is also plus, this is also plus, this is minus, this is also plus. Now look at it. When it comes from plus to plus, no sign change, no time sign changes here. No sign, because plus to plus, no change. Then plus to plus, no change. Then plus to minus, yes, one time sign changes. Then minus to plus, another one time sign changes. So here one time sign changes, and here one time sign changes. How many times altogether?
2 times.
This is 2 times sign changes. So we can write here then the 2 times sign changes, 2 times sign changes in the first column. First column. So there are 2 closed loop poles located on the right half S-plane. So the system is, the 2 closed loop system is, so the system is what? Stable or unstable?
Unstable.
Good, unstable. Because if one closed loop pole is located on the right half S-plane, it will make the system unstable. So there are 2 closed loop pole already. So it is very much unstable. So closed loop pole is located. So the system is unstable. This is your answer to the question. All of you understand it? Any question?
Sir.
Yeah. If any question, you can ask me. Otherwise, I'm going to give you a question and you solve it. Hey, Dax, any question? No. No. Then you can jump to the problem 2 a bit faster. See whether you can do it or not. Okay, the question is like this. This is the canonical form of a system. The equation for the transfer function is 100, 1000 divided by s plus 2, s plus 3, and s plus 5. Now, can you find system stability using what? RSC, Ruthian stability criterion. Now you go for solution. Go faster. Let's see whether you can do it or not. If anybody get the answer, let me know a bit fast. All you have to do first, what? Anybody can tell me what to do? What will be the first step?
C by R.
Good, excellent, beautiful. C by R you have to find, which is G plus 1 plus G. H is 1, so you can find it. Straight away, you can find this equation. That's it, your job done. What you are getting there? You're getting here plus 2 plus 3 plus S plus 5 plus 1000. That's it. Then the lower part equal to 0 is the characteristic equation. Characteristic equation that the whole thing equal to 0. And from this characteristic equation, you have to find the Ruthian array. From here, you find the Ruthian array. And that Ruthian array, once you can construct, you can easily sell. You can tell me what will be the. Now tell me, system is stable or unstable? How many times sign changes and stability of the system? Bit faster. Anybody done it? Okay, the Ruthian array. What is the Ruthian array you have developed? The equation first, we have to go, and then we have to go for the Ruthian array. What is the equation you got? S plus 2,
Sir,
go. S plus 2, S plus 3, S plus 5 into plus 1000, right? 0. After simplification, what do you get the equation? Polynomial. Can you tell me?
sir,
S
S cube
Go ahead.
plus 5s square
5s square,
plus 6s
6s.
plus 1030.
Good. Now, the Ruthian array, if you construct here, then what is the Ruthian array you got? S to the power what here?
Cube, sir.
Cube. Then S to the power square 1 and S to the power 0. Right. Now,
Yes,
if
sir.
you go for it, then what is the equation? What is the first column? Can you tell me the first row?
So 1, 6,
1, 6. Then second row?
5, 1030.
Good. Then what is the next one?
Minus 72,
Minus 72. Then,
0.
okay, then
1030,
0, 0,
then 0.
0. Now, this done. So, this is the first column. How many times sign changes?
2 times
Again, the 2 times sign changes system. What?
is unstable.
Okay, so you have to write in the exam 2 times sign changes. That means there are 2 closed loop poles located on the right half S plane. This is first thing you have to write. Then you can write it is unstable. That is the final decision, unstable or stable. That's the way you have to answer to this question. I hope that all of you understood. Now I'm giving a long polynomial and you can check whether you can go for it faster, but very fast. All of you should be very fast. Problem number 3, and then we'll jump to the special problem. Okay, if this is QS is given there as a 3s square, 3s to the power 7 plus 9s to the power 6 plus 6s to the power 5. So you have to prepare mentally this top question to answer. 4s to the power 4 plus 7s cube, 7s cube plus 8s square, then plus 2s, okay, plus 2s plus 6 equal to 0. So this is the characteristic equation. Find stability using RSC. Go first. This is given already, the polynomial, and now you all have to do the calculation and tell me the answer. Read faster. Have you copied the question? Okay, I'm going to switch to the next one. Special case 1. Number 1. Okay, anybody could do it? Straight away, you need to know this, how to do the calculation. How fast you can do the calculation, that will be reflecting here. Okay, it will be started from S2 about 7, 6. So 0. Now, if anybody done it, can you tell me what is the first row? First row will be what?
3672.
Okay, 3, just a minute. 3, 6, 7, 2. Then next, second row.
9486.
9, 4, 8, 6. Good. Now, if anybody had calculated the third row, tell me the answer. And all of you check the answer.
4.67.
This one is 4.67. Okay. Then next.
4.33.
3, 3. Everybody check correct or not?
00.
0, 0. Is it correct what she said?
Yes, sir.
Okay. Then what is the second row? Anybody calculate it?
Minus 4.35.
Minus 4.35. Then
6.85.
6.85. Then
5.14. 5.14.
5.14. Then
0.
0. Is it correct? Check everybody. These two are correct or not? Okay, I'm just asking everything. You check everything. Is she correct or not? Or you got different answer? And asking you to calculate again, was it correct or not? Check it. This is the problem. How come you take longer time? You know that this one is going to be multiplied with this and minus this, divided by this, you are getting this. But next, if you multiply this is 0 here. 0 multiplied this, then what will be? This will be straight away 8, and this will be straight away 6. Got it now? So multiply by 6 and 0. Hey, you understand?
Yes, sir. Now I recalculate it and find the error.
What is that value? 8 and 6.
8 and
should be 6 because that multiplies 6 minus 0 into 9 divided by that. So it is 6. Okay.
Yes.
What's the answer now?
Sir, 860.
So this is not correct then. You mean this two?
Yes, sir.
This is 8, this is 6, this is 0. And this is 4.3. Is correct or not? Hey, rest of you doing what?
One is correct, sir.
Correct or not? Is correct?
Yes, sir.
Correct, sir.
Okay,
Yes,
if it
sir,
is
correct.
correct, then why don't you tell me the next one? Why are you wasting time? Someone can tell me the following one. Next row. Anybody calculate the next row? Yeah, you yourself. Who is talking? Yeah, who is talking? Please tell me what's the next one. Maimuna Pranti, you are talking about the calculation?
Yes,
or?
sir. I didn't calculate
Oh, you didn't
further.
calculate it. Okay, no problem. We can carry on. And rest of you, do you have a calculator or just watching movie? You all people are lazy duck. Okay.
We are doing
Anybody? Yeah, Atikur Rahman, what is the answer? Next one.
I haven't done yet. We are doing calculation.
Because very bad in calculation. Third year student, you don't know, engineering student, you should be very fast. Using a calculator straight away. This is the last time I saw everybody could answer very fast. I don't know what you are doing. I cannot see whether you are.
12.9, sir.
What is that?
12.9.
12.9. Okay, next.
Six point four two.
6.44.
6.44. Good. Then what is the next row?
0.
This is 0. What is, oh, this is 0. Okay, fine, no problem. I'm talking about next here. S square coefficient, S square will be what? S square row. What do you do? You multiply these, you multiply these,
12.92.
divided by D. Okay. Yes, what is that?
Sir. Sorry, sir.
What is the answer? This one.
10.16.
7.
10.17.
7
10.17. 10.17.
or 10.17. Okay, 10.17. Okay, what is this one then? Next. 6. What are you doing actually? This one into this and minus this divided by 6. This is 6. Yeah, it is. You don't need to do it actually. Straight away you can put it. Okay, then 6. After that, what? Here, you have to do the calculation here. After this is a long calculation, and that's why all stuck. How to do the calculation, you don't know. How you answer in the exam? 100% sure you have to answer this thing, this question. 100%. If you don't try, you cannot answer. And remember, next quiz will be so hard. 10 out of 10, you never can get. You understand it. You become so lazy because you think 10 out of 10 I'm getting. So no need to work out. I'll catch you next city. Okay.
Minus 0.835.
Minus. Okay. Minus. I'm sorry. Can you repeat minus?
0.835.
865. Correct or not?
835.
Okay. Is it correct what he did? Rest of the duck.
Minus 1.17.
Okay. He's saying that. Is it correct or not? 0.835.
Minus. No, sir.
Minus 1.17.
Oh, that means it is not correct.
No, sir.
Okay. Minus 1.17. How many of you got?
So at least 3.
Okay, can you, this one, can you tell me?
Minus 1.17.
Okay, good.
Yes.
All right, then thank you very much for this answer. I'm writing it here as a minus 1.17. Minus 1.17. You don't know how to do the calculation. You are third level student. I think you should not be given the certificate. And then what will be the here last one? You don't need to do the calculation for the last one. Yes, 6. Straight away 6 is coming here. After doing a lot of calculation, still you are not familiar. Okay, now, hey ducks, how many times sign changes?
4.
Yes?
4 times.
4 times. Good. Because plus, 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 minus, plus, 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 plus. So 1 time sign changes here. Here, 1 time sign changes here. 1 time sign changes here. 1 time changes here. So altogether 4 times sign changes. 4 roll on the right hand. The system is what?
Unstable.
Dumb. Okay, this is the way. Now we jump to the special problem. Can you do it faster? Write the array. Hello. Yeah, have you done it?
Unstable.
Yes, sir.
Yes,
Unstable,
sir.
how you say unstable? What is the Ruthian array you found?
Stable.
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 Stable. Sir.
Stable how? Your s cube, s square, s to the power 1, s to the power 0, right? Now,
Yes,
how
sir.
what you written here? Was
1
1,
1
1, 1, and then
2, 2,
2 2
2, 2. Then how come, what is this?
0.
That's
0
the problem.
0
0 comes here. This is what the problem, because it is plus, and 0 is what? Plus or minus, the question coming there. That's why you cannot decide about it. Now, towards stability, if you want to find, then you have to, when you can read this statement, what is written here. If the 0 presents in the first column, and this is what happened, the 0 is present in the first column. When 0 present in the first column, then you have to go for some sort of special case you have to consider here. And in this special case, what you have to do, you assume 0 as a epsilon plus. Epsilon plus is very much positive, tends to 0, change to 0 plus. This means epsilon is very much tends to 0, means the value is 0.000000000, absolutely last time at the end it is 1. So it is positive 0, like sort of thing. So you can say epsilon plus. If you put this is epsilon plus, then the next one will be what? If you calculate, it will be 2, isn't it? If you're epsilon, then what happened? Epsilon into 2 minus is 0, so 2 into 0, so divided by epsilon, so you are getting here 2 to 0, epsilon cancel, you are getting 2, so you are getting 2 here. So if you look in the first column, and first column is plus 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 2 plus, this epsilon positive, epsilon plus is positive, so you can get positive, so this is positive, so all no sign changes, so no sign changes, so system is stable, means there is no, you have to write, there will be no closed loop poles on the right half plane, on the right half plane, so system is stable here. Yeah, you're right, but this is the way you have to answer to the question, that all are positive, you have to show. I think you got the point, what I mean. Now, if I give you a similar type of problem, then it will become much more clear. Can you please note it down, this problem? Just I'm going to say the problem number B instead of A, that is QS equal to, if you say that QS is something like, what call that, S cube. Can you write it? S cube, right? Say S cube. S cube minus 3s plus 2 equal to 0. Okay, can you find the stability? Find stability using RSC. This is another special case, and you will face the same problem. Can you go faster? Solve the problem for this one. Hmm?
On the third row.
What is the answer? What is the Ruthian array?
1 0.
S cube divided by s square, s to the power 1, s to the power 0, right? Now, what is s cube? What is the equation? Actually, if the QS equation, if you write, you are writing here s. Can you tell me what is the first row?
1 0.
102.
102. Then what is the second row? Hey, Doc, what's the second row?
Minus 3.
Minus 3
This is no,
0.
no, no, s square minus, oh, minus 3, then what?
First row is 1 minus 3.
1 minus 3, 1 minus 3. Okay, you said
That
this
is the
is
first
1
row.
and this is minus 3, like that, right?
That
Okay,
is
now
the
let's look at it. S cube, look at this thing. You have to do like this. Anybody can tell me correctly what is the thing here? Or all of you agree? Hmm.
1 minus 3 for the first S
First
cube.
one. That's the thing you have to tell me. Good. 1 minus 3. Then what? Jumping 1 minus 3. Then 1. That's right. 0 2. Okay, now let's sum here. S cube 0. This is look plus 0 into s square coefficient minus 3 into s to the power 1 plus 2 into s to the power 0. This is the way you have to rewrite the equation. Then it is 1 into s cube. Then 1 1 and then minus 3. This is taken later on, so you can get this correct. Okay, now what is the next one? Okay, now look at it. If the 0 is present in the first column, so you have to consider this is epsilon plus. Let it is epsilon plus. And what will be the next step will come in here? Minus 3 epsilon plus
minus 2.
minus 2 divided by epsilon plus. And then it will be 2. Now, this is what you can say. This is plus, and this is epsilon plus is also plus. But what is this got? Plus or minus? Hey,
Minus.
minus. Because this is giving you negative. Why negative? Because this gives you the minus epsilon plus 2 divided by epsilon plus. That means what? The whole thing, epsilon is a positive, 2 also positive. So the whole thing positive and the minus sign is coming because minus you take out, right? Come on. You understand it?
Yes, sir.
That's why negative. System is what? How many changes? Come on. How many
2
times?
changes.
2 changes.
2 times. 2 times changes, 2 close loop on system is dumb,
Unstable.
unstable. That's the way you can do. Or the alternative method also can do here. Alternative one. Alternative one is if you can let s equal to 1 by x, if you consider here, x equal to 1 by x, what will be the equation coming in that case? 1 by s is coming 3s s cube minus 3s plus 2. That means minus s cube. The 1 by x cube minus 3 s means 3 by x plus 2 equal to 0, the equation. And if you do this, then what you're getting here is a 2x cube. Come on, minus 3x squared plus 1. Are you okay? Now, if you go the Ruthian array, x cube square, x to 1, x to 0, what will be the equation coming here in that case? Can you tell me? It is coming here as a what? 2 and then
0.
next 0, good. Then coming here is a minus 3 and 1. And what will be here? Can you calculate and tell me? Come on, first. Ducks.
2 by 3.
Huh?
2 by 3.
2 by 3, good. Plus or minus?
Plus.
Plus. So plus 2 by 3 here. 2 by 3. And this is 0. And this one will be 1. So Is it? Yep. How many times sign changes?
Two times.
How many times sign changes? Sign changes equal to 2 times. Two pole. You have to write 2 poles on the right half, 2 closed loop pole on the right half. Plan system is answer. So it's the same answer you got. Last time also got 2 terms answer. This is also same, right? Alternative method. Now I hope that you all got it. What to do now? I'm giving you a different type of problem. Another special. This special is a little bit different, and you can first of all you copy the question and then you try to write the answer. Okay, question is like special question is I'm writing here the special problem. It is your we can say presence of, you can write presence of 0 rows. Presence of 0 rows. If the present of 0 row, not rows, present of 0 row, if the whole row is 0, then what will happen over there? That's a special problem. Like you can put it here as if you can write it s to the power 5, like s to the power 5 qs equal to s to the power 5 plus you can write 2s to the power 4 plus you can write 24s cubed plus you can write 48s square, the 48 as a square, and then you can write 25s minus 50 equal to 0. So can you do this problem? Just go faster. Try. And tell me, first you write the Ruthian array, and then you do the rest of the job. Question is same. Find the stability using Ruthian array. RSC, Ruthian stability criterion. See whether you can find a solution of it. First, anybody could solve the problem? Or you are stacking somewhere?
A row consisting of 3 zeros I have got.
You got it? Okay,
Yes.
3 zeros in God. Can you just then tell me, good, what is the Ruthian array you got here? We can have s to the power 5, s to the 4, s to the power 3, s4, s square, s to the 1, s to the power 0. Now, can you tell me what is the Ruthian array you got? First,
154 minus 25.
okay, can we just redo these things here? Yeah, I understand it. I'm just going to rewrite here. We need some spaces there. Okay, there's the Ruthian array we can have here as a s to the power 5, s to the 4, s cube, s square, 1 s to the 0. Okay, so you are saying that it is 1, 24, then minus 25, right? And what is that? Next, 2
248 minus 50.
minus 50. Now, what is the third row?
0, 0.
All 0.
Yes, sir.
Okay, so we can say this is the 0 row present in the uh, in the array. So this is your 0 row. 0 row. That's what I'm talking about. Presence of a 0 row. So this is the 0 row present here. Okay. So whole row is 0. If this is the scenario, then what we have to go for to find the solution, we have to take the auxiliary equation. The auxiliary equation should be taken from the above row. So the auxiliary equation should be taken from here. The auxiliary equation. Auxiliary equation should be taken from here. What is the auxiliary equation? The 2 is multiplied with s square, s cube. 48 will be s square and 50 will be s to the power 0. So the auxiliary equation will be like 2s square, s to the power 4 plus 48 s to the power, I mean s square plus, I'm sorry, this is minus. Okay, minus 50 s to the power 0 equal to 0. This is the auxiliary equation coming from here. Got it?
Yes, sir.
Okay, good. So these 2 will be multiplied s to the 4, 48 will be s to the power s square, and 50 will be with the s to the power 0. And that's the equation. Now, after getting the auxiliary equation, if it's a 0 row presence, now how to solve the problem? When it is coming like that, then what you do, then you have to take the, after getting the auxiliary equation, you have to take the derivative, first derivative of this thing, dds of this thing. And then we are getting what? What is that? If you take the derivative, 8s cube, then 8s cube plus, can you tell me 48 into 2?
96.
What?
96.
96.
96 s to the power 1 plus 0. This is equal to 0 because 50 is 0, right? Derivative of a constant. So this is what you got, 8 and 96 as a coefficient of s to the power cube and x to the power square. So this is the x to the cube coefficient, so which is 8, and it is the coefficient of s to the power 1, which is 96 here. So 8 and 96, these two values you're getting here. That's the way this 8 and 96 will be taken into the 0 row. After getting 8 and 96 here, replacing this, now can you do the calculation again and see what is the answer coming? Now do it. This is the way to go. Faster. Yep. What is the answer? Can you find it?
24 minus 50, 0.
Okay. So you got the answer here. This value is 24. Then this one is
Minus 50,
0. Then next one,
0.
next row.
112.67.
Come again, please.
112.67.
112.67. Then
0, 0.
then minus 50.
Minus 50, 0.
So it's all right. So system, how many times sign changes?
1 time.
How many times? One time.
One time.
One time means how many poles on the right half plane? One closed loop
One.
pole on the right half plane. You have to write this statement, remember. System is what?
Unstable.
Still unstable, because at least one pole on the right half plane means system is unstable. Okay, this is how we can get our a different type of problem based on the Ruthian array. Yeah, using Ruthian array, we can find. Now, I'm going to give you some examples to solve at home. All of you, please. Yeah, sir, go ahead.
Do you need to show the calculation, or we can find the value in the calculator?
I'm sorry, I cannot clearly understand because your voice is not clear. Okay, anybody understood what he said? Can you
Hello?
repeat? Yeah, can you
Do we
repeat?
need
Go.
Do you need to show the calculation?
Show the calculation. No, no, you don't need to show the calculation, because your calculator can show do it, and then it doesn't mean you can copy from others. In the exam, it will be copied. Now let's come back to the point. You copy whatever the thing I'm giving you. You have to solve this problem at home. Okay, so all what you have to write the question number 1. First of all, C by R, you can write here. This thing is 10 over. All you have to find stability. Find stability. Stability using RSC. This is the question actually. Now divided by, you can write s to the power 5 plus 2s to the power 4 plus 3s cube. 3s cube plus 6s square plus 5s plus 10. Now this question I'm giving here is your to solve the problem at home based on the knowledge you got already. And I already uploaded the problems in the what we call BUX, some practice problem. Those things you can solve after next class. In the next class, I'll show you how to find the controller gain and how the controller gain can affect the system stability. It means range of the gain for finding the stability. Next class, I'll show you, and then you can solve the the practice problem that what I have given in the BOX. At the moment, maybe you can't. So next class onward, you can do it. Now, this is one of the problem you try at home. Then you copy the second one, which is this one, C by R equal to another one. We can write 100 divided by s to the power 5. S to the power 5 plus 7 s to the power 4 plus 6x cube plus 42 s square plus 8s plus 56 plus 56. This is what the problem. And number 3. Okay, and number 3 is like this got the QS equal to 0 equal to, you can say s to the power 5 plus s to the power 4 is 3s to the power 4 2s cube plus you can write 6s square plus 6s plus 6s plus 9. This is one of the problem you can solve as well. And number 5, you can try QS equal to s to the power 5 plus 5s4 plus 11s cube plus 23s square, then 28s plus 12. Okay. Okay, these are the problems that what you have to solve at home for the time being. And next class, I'll show K determination. K determination after finding the K determination after next class, actually you can find the solution or you can solve the problem which is already uploaded in lecture 13, next lecture. All the practice problem you can solve after getting the K determination class, next class, and then you can solve the rest of the part. And that's the complete, what do you call that, Ruthian stability criterion with this class and next class together. And after that, we'll go for the Nyquist criterion in frequency domain analysis. So that's all about for the class today. If you don't have any question, then we can close the show. Have you copied already this thing?
Yes, sir.
Okay, good. All right. So that's the end of the class today. So if anybody got any question, you can stay back. And if you have no question or you have another class, you can leave the classroom. I think I can allow you to go. Thank you very much for having staying with me till the end of the lecture.